This video is about systems of equations. You will learn that there are several ways to solve systems of equations. First, we need to understand what a system of equations is. A system of equations is two or more linear equations involving the same variables, and that is how you form a system of equations. Now to determine how you get your solution. A solution of the system of equations is an ordered pair that satisfies not only one equation, but actually both equations. There are three types of solutions. The first type is when you have one solution, which is created when you have two intersecting lines. As you can see, these two lines intersect at one point. That one point would be right here, where that red dot is. Parallel lines will not have a solution because, as you know, parallel lines never intersect. So your graph would look something like this. Notice the slopes of the lines are the same. The third type of solution that you can have is infinitely many. When two lines are exactly the same, they would lie on top of each other. Therefore, they will have infinitely many solutions. Every single ordered pair on that line would be a solution. The first method that you will learn today is called the graphing method. When is it best to use a graphing method? If you have both equations in slope-intercept form, the best method is going to be using the graphing method. Now I'm going to show you a few examples of how you solve these. Note, make sure equations are in slope-intercept form. In example number 1, notice how both equations are in slope-intercept form. I'm going to first graph the first equation, which is y equals x minus 8. The slope of that first equation is 1, and the y-intercept is negative 8. With a y-intercept at negative 8, I'm going to go down to negative 8, 2, 4, 6, 8, and I will then graph my equation. Notice I have graphed my y-intercept. Now I will go up 1 and over 1, up 1 and over 1, to create a line with the slope of 1 with the y-intercept of negative 8. Using a straight edge, you will then create the line. There is my first line. Now I will graph my second line, which has a slope of negative 2 and a y-intercept of 1. With a y-intercept of 1, I will start at positive 1, and I will go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I will now connect these points to create my second line. Notice how these two equations cross right here. The location of that intersection would be your solution to this particular system of equations. The ordered pair would be positive 1, 2, 3, and negative 1, 2, 3, 4, 5. So the equation, both of them, converge at positive 3, negative 5. And there's your solution for number 1. Let's take a look at number 2. Again, notice both equations are already in slope-intercept form. So we can go ahead and plot them. The first one has a slope of 1/2 and a y-intercept of 9. I'm going to go up to positive 9, 2, 4, 5, 6, 7, 8, 9, and draw my y-intercept. Then I'm going to go up 1 and over 2 to create another point. However, I cannot go up and over anymore, so I'll have to go back to my y-intercept and go down 1, left 2, down 1, left 2, and so on. Now that I have these points, I'm going to go ahead and connect them. There's the graph of the first equation. Now I will plot the second equation, which has a slope of -1 and a y-intercept of 6. So 2, 3, 4, 5, 6. There's my y-intercept, and since my slope is -1, I go down 1 to the right 1, down 1, right 1, and so on. I will then use a straight edge to create my line. Notice that these two equations intersect each other right up here. That ordered pair is going to have an x value of -2 and a y value of +8. So there's the solution to this set of equations, also known as a system. For example number 4, you'll notice this first equation is not in slope-intercept form, so you must change it into slope-intercept form. Here are your steps. Step 1, you will subtract x from both sides. Step 2, you will then divide both sides by 2. Then you will have your slope-intercept equation, y equals -1/2 x plus 2. Let's go ahead and plot this first equation. Your y-intercept is at +2, and your slope is -1/2. So you go down 1 to the right 2, down 1, right 2, down 1, right 2, down 1, right 2. You can also go back to your y-intercept and go up 1 and go to the left 2, up 1 to the left 2, up 1 to the left 2. Now take a look at your second equation. Notice the second equation is the exact same equation as the first equation was. Therefore, this would be infinitely many solutions. And to show that you have infinitely many solutions, you will draw the infinity sign. The reason why there's infinitely many solutions is because these two lines lie right on top of each other. Therefore, every ordered pair on the line is a solution. Example number 6. Notice your first equation is y equals x plus 5. That's a y-intercept of 5 and a slope of 1. I will go ahead and draw my line by connecting my points. And there's my first equation graphed. The second equation needs to be changed into slope-intercept form. First thing you will do is subtract x from both sides, then divide both sides by -1 to give you y equals x minus 2. Let's go ahead and graph this line. The y-intercept is at -2, and the slope is 1. So you will go up 1 over 1.